Hello class, this is Module 7, it's out of Chapter 10 in NAP, regarding the chi-square. And we're going to do three things in this module. And we're going to solve statistical problems for categorical data. We'll talk about that using the chi-square. Number two, we're going to continue your course project by providing a sample table of data and then adding 3 to 5 research questions and hypotheses. And then number three, we're going to answer a set of questions, I think it's 10 questions about the chi-square terms and procedures. So let's start talking about the chi-square. The chi-square shows the relationship between categorical variables. And up until now, we've been using other kinds of variables, continuous variables, to do our calculations. So we're going to talk about what categorical variables are and how they're used here. The chi-square determines the relationship between categorical variables, and here we have two categorical variable sets. We have gender, girls and boys. That doesn't have any order to it, doesn't have any value to it, one greater than the other or anything like that. Ice cream, the same way. It's choices. They're not ordinal. They're just not scaled in any way. It's not there. So we can compare these though using something called the chi-square. What we're going to do here in a moment is look at an example. But first, this word dichotomous, you may see this. That means two values, like girl and boy. SES status, like high and low. Now that kind of has an order to it, but not in the way we think of it in solving using values ordinarily in a Likert scale. Here's some that would be called polychotomous, school duration schema. You either have the traditional year-round school, or in this case, the 4-day week, traditional or year-round or 4-day week. That's trichotomous, I guess. And you could come down here and look for another one here, personage, good, bad, and the ugly. Yeah, well, it can be either way. Chi-square, let's get into an example. Acme Creamery wants to discover if girls and boys have the same ice cream flavor preferences. In other words, is gender, girl and boy, a relevant factor when it comes to favorite ice cream flavors, chocolate, strawberry, or vanilla? Hypotheses, again, we're changing things up here. We're becoming a little more sophisticated. The null hypothesis. There is no significant statistical association between gender and ice cream flavor preference with an alpha of 0.05. That's where we're going to test everything to. Significant statistical association. Chi-square measures an association. You'll hear the term the chi-square test of independence. It's better if you think of it as being an association. The motivated hypothesis, there is a significant statistical association between gender and ice cream flavor. If that's true, they're saying that whether you're a boy or a girl, you'll choose a different type of ice cream. Here's a survey to gather the data. And the ice cream survey, what's your gender and what's your favorite flavor? And to interject right now, most surveys often are solved or resolved by use of the chi-square. Just keep that in mind if you're doing a survey. There is a pretest checklist. The cell values, and we'll talk about what cells are in a minute, have to be greater than 5, and it says check after chi-square test is run. We'll talk about that. The pretest, you do look at it before you begin because it can tell you if the chi-square is going to hold up or not. But anyway, if you're looking, this is a 2x3. It's not a contingency table yet, but it is sort of. I'll show you what a contingency table is. But what we'll want to do is make sure the data that fills this table when we start with, we're hopeful that all the values in each one of these cells from our survey will be equal to or greater than 5. Well, look, here's the data. Girls, 22 like chocolate, 10 like strawberry, 14 like vanilla. Boys, looks like their preference was strawberry. Let's go on with this. But what if we had gotten our results back and they look like this. 23 girls, the girls like chocolate, 10 like strawberry, and 13 like vanilla. 4 boys like chocolate, 34 like strawberry, and 12 like vanilla. Well, there's different things we can do, and we'll discuss it as we go along. But right now, we're thinking this violates the pre-checklist, but does it? And we're going to talk about this. Here's how you run the test. We'll come back to that. This is how you run the test. You click Analyze Descriptive Statistics, and you go to a place called Crosstabs. That's where you're going to run the test from. The videos will take you through this item per item. After you get to the next slide on your SPSS, you'll check chi-square and continue and go from there. Now, again, it says pretest checklist is in greater than or equal to 5. And it says checked after the chi-square test is run. And I'll tell you why. This doesn't tell you that, because this tells you what the data is, like it was in the first set of tables. This is a true contingency table. It has some variables down the left side. I like to call these the dependent variables. And across the top, it has the independent variables. But notice every one of the cells have more than 5. But notice we've added something, the total. This 46 is the total across here. This 50 is the total of these going across this way. This is the vertical totals. And this is what SPSS on the inside is looking at. It's looking at these totals and what these values are, and it's going to be comparing them to something. And here's what it's going to be comparing. You have your actual values. And we can look at that table and say, well, I'm pretty sure, I think that the overwhelming majority of girls like chocolate, and the overwhelming majority of boys like strawberry. But we've got to have that 0.05 level satisfied, so we've got to figure that out. Well, your computer looks at all this, and it determines what the expected, see this term expected values are in each cell. These are expected based on looking at all of these numbers here. And I'm not going to go into the calculation of that right now. It's not very difficult at all. But you have 15.3 are expected in this cell. 19.2 were expected in this cell. Whoops, they only had 10. That looks like a significant difference to me. And so on and so forth. But anyway, that's what your computer is looking at when it solves the chi-square. And here is when the actual is less than 5, but expected is greater than 5. Watch this. Look, on the surface, we look at this. This is a regular table here. We said, well, we don't satisfy the conditions because one of the cells has less than 5 and it has 4. That's not always true, because what the real test is the expected values. You have to look at what the expected values are in the cells before you do something besides the chi-square. And look at the expected value for boys in this table. Well, as long as the expected values are all greater than or equal to 5, you can use the results of the chi-square. And your videos will tell you what to do when they don't satisfy this condition. So we'll not spend that time here on it. But these are contingency tables. This is a contingency table of the actual values. Here's a contingency table of the expected values. And notice that the row and column sums are the same in both tables. Okay, let's go back to the test we were running. We'd gotten through the analyze down to crosstabs and check chi-square off, and here's the data we were working on. Let's see if it's true that there was some kind of a significant difference and that boys liked strawberry and girls like chocolate, and that was an association. There was a dependent relationship on whether your gender as to what kind of ice cream you liked. Results. Okay, here's the result table of a chi-square test. So, and we're going to look at the Pearson chi-square. Here's the value of the chi-square, and you're going to look. You'll watch a video later that tells you what that 15.026 means and where it comes from. Degrees of freedom are 2. If you remember that, how you find the degrees of freedom, we'll talk about that some more at some point. But look at the significance. 0.001. That's highly significant, a lot less than 0.05. So the result is there was a difference in ice cream preference for girls and boys. Look at these terms here, likelihood ratio. We use that to determine if there's significance when the expected values are not satisfied being greater than or equal to 5. You'll see that in a video on how to use that as well. Here's the results in terms of a graph. Chi-square is good at making a graph for you. Girls' preference for each of the ice cream, chocolate, strawberry, and vanilla. And the abstract, typical abstract, according to the survey, 96 children were detected. We detected a statistically significant difference. La 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 la. You can do this. Here's an alternate presentation. In the alternate, here's the same presentation we just made. But in this presentation, the chi-square contingency table is a little different. Let me move this over a little bit here. See if I can get that in there. Let me go back one. Yeah, here it is. Right here. I think we've got it all in there. This one, notice that instead of girls and boys down this side, we've got chocolate, strawberry, and vanilla. You can set up your contingency table any way you want. I have a preference, and I'll tell you what that is in a minute. Looking at the graphs, you see how the graphs were for the first one and how they are for the next. Here's what I recommend, however. This is pretty customary in the way people set up their contingency tables. They set it up with the dependent variables down the left side and their independent variables across the top. So just keep that in mind. That's pretty contemporary as far as what people do. Part 2 of the course project, you're going to continue with the course project. And based upon your choice of information from previous submissions, your dissertation topic, purpose, significance study, all of that stuff you've been doing, overarching questions and hypotheses, you're going to provide the following information. You're going to provide 3 to 5 research questions that you're going to draw from the overarching research question. And I'll show you how to do that in a minute. And you're going to state, for the null hypothesis, you're going to state 3 or 4 null hypotheses because there's more specificity when you get to this point than the overarching null hypothesis. You're going to have to determine what data you will need to answer the research questions and determine the outcome for your hypothesis or hypotheses. This is important. You're going to construct a sample, fictitious data table of the data with from 15 to 20 data points. Sometimes that's not enough, and I'll show you why. I had to put about 40 pieces of data in the one I'm going to use for an example. So you might want to try to get as many as 40 pieces of data for your thing. You can use either SPSS or Excel. And I say here you will probably want to use Excel, but after I did, I thought I should have put this in SPSS to start with. And so maybe you want to practice that. But you're going to present the data table with your data in it, columns and rows, and then you're going to give the descriptive statistics, number 5 here, right? And I'll show you how to do that, what I'm speaking of right here, what I'm talking about. For each hypothesis, indicate what statistical procedure you might use if you know it. If you don't worry about it. We'll talk more about it later, but try to make an educated guess. So provide from 3 to 5 research questions. If your overarching research question was, here's an example, how is student performance for students receiving special program services affected by the school year duration schema? Well, before we would have talked like this and spoken about these terms, we would have defined them somewhere in the study, and we're not going to make it through on this particular first video. So I may actually do another one, and I'll start here when I do.